think you can hear me now. Good morning. Early morning today. Thanks for coming. My name is Alwyn Viemeister. I work for the Windows Store team, and we develop the Windows Store as well as provide commerce licensing functionality on the client and Windows APIs, Windows runtime APIs that you can get to from your application. So you can do your own commerce through our APIs. What I'm going to talk to you about today is purchase validation. And there are two reasons why you want to do purchase validation. One, make sure you're giving your customers what they paid for already. And secondly, protect the investments that you have in your client and also on your service from non-genuine use. So an ISV, just like you, long time ago, back in '76, was having similar troubles trying to get his clients to see the value in the software that he was providing them. And he implores, I know that you guys love the software that I'm building, but, it would be great if you paid me. A lot of you are making money off of this stuff too, so, if I continue doing this, I'm basically working for about $2 an hour, and that's, we'd really like to provide some value in this. And towards the end of the letter, he says, I would love to, have you guys send me money. Think of all of the developers that I could hire to create great software for you and increase this, virtuous cycle of software. So making money off of your software is not a new problem, and also protecting your software from use that you don't want it to be used in is also something that's not new. So one of the things we decided to invest in, and this is investments that we started in Windows 8, was validation for you for some of this functionality. So you wouldn't have to build everything from the ground up. So what is the validation that Windows provides for you to make sure that your application is being used in a genuine state? So the first thing that Windows does is it provides app integrity validation. So when you submit an application to the store, we go through some lengths to verify that it's a real application, that there's no malware in it, that it's appropriate for the use that your customer wants to have. Once that's done, we take the application and we sign it with a certificate. So it's cryptographically signed that these binary bits are the ones that you submitted and the ones that your customer should get. That signature is used when you download an application as a customer. It verifies that the binaries that are being downloaded and come down through the pipe are exactly the same ones that were submitted by the developer. When it installs it on the machine, the same thing happens. The validation makes sure that it's the same binary bits. And regularly, even after it's installed on the box, Windows will go through and do the same check. The signature is stored on the files next to your application, and it can see if someone has tampered that application and will take actions appropriately. Another thing that Windows does built in for you, through the Windows Store, it provides you a license, which is a policy file. So say, for example, as a developer, you want to do a trial for your application. You have like a $5.99 or a $5 app maybe, and you want to encourage people to download it and try it for, say, 7 days. So one of the things that the policy will be in the license, it will say, this is the expiration date. It will say, you're allowed to use it on this particular machine. And that gets brought down to the client as well. So that's the second piece. The last piece that we do is we take the first two and we evaluate them on a regular basis. Windows looks and makes sure that these are still valid files that are on the system, as well as a valid license. So if your trial has expired, for example, it's no longer a valid license to run that application, and Windows will prevent it from running. Let's take a look at a case where maybe potentially some malware has attacked your application store and has modified it to do things that you didn't intend it to do. Or a user maliciously modifies it to maybe get some of your service without actually having paid for your application. So what they will see when they go to launch your application after they've made that modification is that there will be a little X. So if you can see on the bottom right-hand corner, there's a little X saying, hey, there's something wrong with this application. And it could be a variety of different things that went wrong with that application. When you try to launch it, it won't launch. And then Windows will redirect you to the store. This is what it will look like. So in this case, I'm showing the sports application. I went in and modified some files in the sports application on my machine and then tried to launch it, and this is what I get. It allows me to go back to the store. When you launch the store through that link, it tells you, hey, this application needs to be repaired, and here's how you repair it. Do you want me to repair it for you? Great. The Windows Store will bring down the files again and restore that application back to the correct state. It knows that you still have a license for it. It'll bring that down as well in case that has also had a problem. So basically allows you to restore the application to a good state. So one of the things that I wanted to talk about is a couple of improvements that we've made to the licensing. So the policies that come down that says how you can use the application. We've improved the ability to do license sync. And let me talk about this because maybe some of you aren't aware of how this works. When you have multiple PCs that you use in your regular life, you can install your applications on several of them. Say on one of them, I'm using in my kitchen, and I do a purchase to be able to get all of the recipes for this particular application. When I actually go to my other PC, that license has roamed from one PC to the other through our service. So if you have a connected account, those things happen automatically. And in Windows 8.1, we've done more work to make sure that that roams well across all of your PCs. One of the things that you might have heard yesterday if you went to a talk, Arik did a presentation, number 121, if you have a chance to go look at it, where we've added consumables as a type of purchase that you can do through your application. So this allows you to do several different things. If you have something that you want the customer to purchase over and over again, so say, for example, you have a game and you want them to buy coins, you can do this through a consumable. You can also use this if you have a very large catalog of items. Say you have a bunch of books in the thousands. You don't want to go through and enter each of those into the App Store catalog. You have your own catalog that you maintain. You can use consumables as a way to do purchases and provide a tier of different price levels for your books that you can sell. And the customer will see the titles that you provide in the API calls. So that's one big area. We've also increased the PC limit. We found that some of our best users are starting to use multiple devices, and within the family, they might have a device per each person, plus a couple of shared PCs, and quickly you get past the 5 limit that we've had up to now. So that's going to be expanded. And you'll see that happen at the general availability of Windows 8.1. So let's take a look at what you can do as a developer. You saw the basic functionality that Windows provides to protect your application. Your application can also do some work to make sure that it is giving the customer what they've purchased, as well as protecting itself from running in a state where it shouldn't be running. A quick little diagram to kind of explain what it looks like. Your application, when you do a purchase, the first thing that happens is you do a transaction with our store, and down comes a policy file. It's a license is what we call it, and that license gets stored on your local machine. That will be there perpetually so that your application now, when you go offline, you can check to see what is the state of the purchases that I've had. And this is very important, again, for the roaming cases. So when you launch your application on machine 1, 2, and 3, check to see what licenses are already on the box and make sure that you light up those features for your customers. That's one mistake that we see developers do, where they will only track the purchase and then keep their own little record of what the customer purchased in the app. And that doesn't necessarily roam to all the other PCs that they've installed their apps, and the users don't get the features that they have. So use the underlying cached information, and then you'll be able to light it up on all the different machines that they have. So let's look at some code. So I've built a very quick application that shows you information that comes from our server about the application and the licensing state of the application. And let me run it, and you'll get a sense for what that looks like in terms of the information you can get. In the top here, in this top half, is listing information that you get from our service. So when you onboard your application, you specify the name of your application, description, you localize it into multiple languages, etc. You also pick a price, and then you specify things that they can purchase in your application. So offer number 1, for example, in this case, I offered it for $1.99, and the name is Product 1. So our APIs allow you to get that information from our service. The second set of information in each column here is license information. So that's what policy is this current user running on their machine. So in this case, we are not running a trial, so it's a full license that we have, and the license is currently active. For the product, the same is true here, but we have an expiration date. It expires on 6/30, so that's actually 2 days from now. At that point, I can make decisions such as upsell it to the customer and say, hey, your expiration is 2 days from now. Would you like to extend this? And so you can offer the purchase as well. So let's take a look at the code just so you get a sense for how you would do this and how you would load those variables into your application so you can use that to check what they've actually purchased. What I'll show you up here is a nice trick that Arik showed me the other day. In both C# and JavaScript, when you do your development, you're doing development against, maybe your app hasn't been published to the store yet, so there's really nothing up in the cloud for your listing information. The store doesn't even know your app exists. Since it doesn't know it exists, there's no way for you to acquire a license policy from the store either, right? So how do you do your development offline until you actually get to that point? We provide a simulator that you can switch to, and it's a different class. It's a static class on the root of our namespace, the store namespace. So when you're doing development, what I've done here is when I'm in debug mode, I will use the current app simulator, and that allows me to load the state of the application and some of that metadata from an XML file instead of from the service. When I switch to actually doing a release of the product, I'll switch to a release mode, and then it uses the actual current app. And that one will talk to our service, it will look at our current license files and policies, and that's the one that you want to submit to the store. So let's take a look a little bit further down at what this is doing. I have some declarations up here that are just basically some shared variables. Not that interesting right now. I'll do a couple of things. I'll do a check at the top to see if my application is running in dev mode, which is side-loaded an application that I've just put on the box, not really store-signed, not licensed, or if it's actually been licensed from the store and I have a license policy on the box. So I will check. Instead of the settings above, I will check the actual current app. I'll check the license information is active. And it's as simple as that. It'll be true or false. So if there's a real policy file, a license file from the service, it will say it's active. And then you know that you're actually running a customer scenario versus just a debug scenario. And the reason this is actually interesting for you is that one of the attacks that people can do on your application is take your code, re-sign it, repackage it, and now they have their own application, but they can't sign it with a store signature, so this won't be working for them that way. And so this is one way for you to detect, hey, my application is not running in a valid state. And the interesting thing about this, it just raises the bar a little bit for someone to try to attack your application. What it means is that now they have to go in and muck with your code. They have to come in and remove this statement so that your application will run in the way that they've repackaged your application. So it's extra work for them to get there. It's not by far something they can't do, but it's just one more protection that you have. So let's look a little bit at the variables that you load, just so you get a sense for how that works. In the listing information, since we're doing a call to our service, it's important that we put it inside of a try-catch, make sure that we handle scenarios such as network disconnected, potentially, the application has other errors that it has to do. Maybe anyway, there's a bunch of different potential issues that can happen because this is an async call going off your box. So what you want to do is make sure that you're trapping the cases here. This is important not just for the app to run, but when it's going through certification, they will test it in various different conditions, and your app will actually crash if you're not handling these things. It's pretty straightforward. It's not rocket science here, but I thought I'd mention it because we do see applications that have that problem. License information, as I said before, is something that's cached on the box. So it's not an off-the-box call. It's very quick. It's in cache. It's also the same information that's used by the operating system to detect should I launch this application or not. So it's available very quickly in your application. And let me go show you at the top the simulator that I mentioned, and I can walk you through a little bit of how this works. When I switch over into my debug mode, we are able to see that instead of loading from the actual API in the local store, we will load the information from this XML. And let me show you what that looks like. This is the XML that you would load for your simulator, and it allows you to play around with the display information that will be in your application prior to you actually uploading it to the store and doing the process. So you fill in some information here, some pretty basic stuff, the name, age rating, kind of the description. And the descriptions here, as you can see, is inside of a market data element. That allows you to have multiples of these for different countries, and so you can play around on your machine, set a different locale, and see what it looks like in German and start testing your interface as well. So that's information for the application. If you're doing some in-app offers and you're selling offers, you would fill in this information as well. In this case, I'd call it product 1, set a price for it, and in the US market, this is the price that it would be. So that's the listing information. That sets the metadata for your application to get from the store. It simulates that part. The next part is the policy information, the licensing. You can say, hey, let me do a test. This full mode XML file will be loaded to verify what my application looks like and runs like when they have a full license. And so in here I specify, yes, it's a true active license, and it's not in a trial mode. It's actually in the full mode. And you can do similar for the products, the offers. So you can say, hey, the user already purchased this product, or you can say they didn't, and then have them exercise that functionality. It lets you test your application in different states. And then the last thing that we have down here is a way to simulate. So listing information, for example, I mentioned that it's important to test cases where you're not connected, for example. Well, if you're using the simulator, you want to force that network failure. So you can go ahead and specify here a couple of other different values. So I can specify eFail, for example. If you saw the list of possible options there, that's coming from an XSD file that I associated with this. I don't know if you guys are familiar doing that. It's something that you can do for your XML files when you look in here. In the properties, you're able to specify a, well, actually I don't see it here, but you're able to specify an XSD file, which is a schema, and that's also available in our documentation. It helps you just make sure that your document, when you're editing, is correct. So let's go back to the code here, and I'm going to run it in the debug mode and see what we get. And that'll load that XML and use that as the source of information. So as you can see, we have different states for the licensing information, and we have like the expiration that I set in there and the fact that it's not in the trial. So let's go back to the presentation, and let me talk a little bit about what we do for beyond your local application. So the functionality that I just showed allows you to verify that your application is running in a certain state. They've bought this product, have bought that product, they're in a trial mode or they're in a full mode, and your application can behave accordingly. The next thing that you want to do is provide an additional level of value to your customers. So say you have a web service. That web service may be registering a purchase that can then be used not only on this platform but on another platform, say maybe a mobile phone or a completely other device, or maybe just on a website that you provide. So you want the purchases from all the different sources to be trusted by your service, and your service is the one that does all the accounting and keeps track of what each user has purchased. So to do that, you need something that can be trusted by the client. So we look at receipts as a way to do that. When you do a transaction with a store, part of what you get back from the store is a receipt. It's an XML file, and that XML file has the license information inside of it so that you can, on the service, validate and use that XML. And I'll show you a little bit about how that works. When you send the application's receipt up to your service can do a couple of different things. It can look, using a public certificate that the store provides you, it can look to see if it's correctly signed by the store. Is this a real valid receipt from the store? Other things that it can do are validate the information inside. And the same as we could do on the local machine and check the licensing policy, you can do on the server with receipts. Some of the scenarios that you can implement based on that. Say, for example, you have a certain value that you provide on your service, and that service is not free. You're actually paying to run it. All the hits that you get are going to cost you money. So you want to make sure that you're servicing your genuine customers. And also, if you have, for example, in this case, the Solitaire has the ability to do achievements on the web service. If you don't have a receipt, a valid receipt, it literally won't let you connect to their service. And so this is one way that they protect the investment that they have in their service. The user can go to the store and get signed in with their actual account that they did the purchase, and they'll be able to go into the application. Another example of something that you can do is you can have a policy where, say, for example, you're distributing some content that you are getting from a third party. That third party has restrictions on how you can stream that content to your customer so that they can only use it on 2 devices, for example. So you can implement a policy on your server that only 2 devices can be used for this particular receipt. And I'll show you how that code works. So let's switch over, and I'll show you some code. And this code will talk about how to validate the receipt up front, and then also how to look at some of the information in the receipt to do some of these policies that you want to implement on the server side. So let me switch over, and we'll look at, first of all, what happens on the client side to send up that receipt, and then I'll show you from the server side a little project that accepts that receipt and does the validation. So in this section here, towards the bottom of my load variables section, I will actually call the store and try to get the receipt. So in this case, I'm making a call to the Windows Store and say, hey, get the receipt for this application. And that receipt will come back with information about what I've done, the purchases I've done, when I've actually bought it. And this is what the receipt looks like. Has some information about itself, the receipt date. This is when the server actually generated this document, this signed receipt. I'll explain more about the certificate ID shortly. Then we have information about the app itself, what the name or the identity of the app is, so that your service can say, oh, yeah, I recognize it's from this application that I published. When the purchase for that particular application was done by the customer. And then the type of license that they have. Again, if you were running a trial, there would be an expiration date as well for the application. And then for the product receipts, the same similar information, the product ID, expiration date if there is one, etc. What type of product it is. If this was a consumable, it would say consumable here, and it would have some additional pieces of information, a transaction ID, for example, that would come in through there. And then the last thing you see here is a signature, and the signature is what allows you to trust this document. Up at the top, there's a certificate ID, and this is the thumbprint that is of that certificate that validates, allows you to pick which certificate to use that we provided you from the store. And I'll show you in code, and it'll be a little clearer there. So let's take a look at what on the server side, what we're doing. And I did a very simple project up here. It's an MVC project. When a receipt is sent up to the server, I send it up as XML in the body. It's a post message. I extract it from that and then set it onto this model. The model is basically one class, a receipt class, has some status variables at the top. Is it signed? And some information that I then check about that license that we'll walk through. This is the variable that actually stores the XML that gets sent up, and then I do some processing on it. So when the variable is set, I'll go and do some initial processing. So the first thing that I want to do is check to see if it's a Windows Store signed license. That's the first check you want to do. You want to make sure that it actually is a good receipt. Otherwise, you can pretty much stop at this point. No need to let the user come through anymore if they don't have a valid signed receipt. And these are the basic steps to check to see that the certificate, that the receipt you got back is valid. There's a certificate ID element at the top of the receipt that we looked at, this guy right here. That's the thumbprint of the certificate used. So Microsoft provides in the Windows Store a way for your application to download this public certificate, and that's what you're going to use to do your testing against. So I've cached it locally because it's one and it's not going to change for a long time. But this certificate, when I get it back, I can then pass it in. By But in the case that Microsoft changes the certificate that we use to sign these receipts, your application can also dynamically download it from our site. There's a function here I created that allows you to do that. I'll show it later. So in the end, you get a certificate that you can then pass into the XML DSIG validation. So this function here implements basically an XML signature validation function. This is something that is, there's many implementations on the web that you can use. Our MSDN documentation contains one example. This is the one that I've implemented here. But basically all you do is pass in the receipt and the certificate, and it comes back saying yes or no. And that tells you two things. One is it tells you it was signed with a certificate that you think it was signed with, that the store provided you, and that the rest of the document is intact. So it provides you both of those pieces of knowledge, and now you can say, I believe that this was actually a real receipt that was signed by the store, and I can trust it. So what do you do with that information? So the information that you have now is, okay, I can trust it, but this allows you to do the first thing, which is give your customer what they bought. The second thing that you want to do is to say, well, maybe this receipt, even though it's a valid receipt, is being used in a way that it shouldn't be used. And there are ways to do that. So one of the things that someone might do is they say, oh, hey, I got a good valid receipt. I'm going to take that receipt. I'm going to put that in my own application. And now I can just send it up whenever I want. And I have free access to your services through my own APIs. And I can get to your application and do whatever I want. So one of the things that you'll want to do is use the fact that that receipt is dated and signed. So here what I'll do is I will check to see how long ago was it signed. And I'll set a policy on my server to say, hey, if it wasn't signed more than 10 minutes, if it was signed more than 10 minutes ago, I won't trust it. This is potentially being replayed. It's on someone's application. They've hard-coded it. So again, very straightforward. I'm just looking for the receipt date inside of the top element. And if that's value is less than 10 minutes ago, then it's good. Otherwise, I will reject it and say that it's not recently signed. So that's one very simple check that you can do on your server side to prevent the replay attacks. Another thing that you should do is make sure that you look at the policies inside of that. So if you implemented a trial, for example, you want to make sure that even though it's a valid license that you got, that it's not actually being replayed as something that's already expired. So here all we're doing is looking at the expiration date. And if there is no expiration date, then they have a full license and they're good to go. If there is an expiration date, we just take a look at it, make sure that the expiration date's in the future, and then we allow it in. So again, a pretty very simple check that you can do. So let's talk about one last thing. I mentioned that some of you might have some policy constraints from your providers of the content that you have, and you might have limitations on the machines. And this is where I can explain a little bit about what the receipt is, some of these identifiers. So you'll see that for the application itself, there's an identifier here. That's a unique identifier for that purchase. What that means is that that user, at that time, in your application, made this particular purchase. So those three pieces of information become a unique number that's hashed into this GUID. So this GUID, say for example, if your customer comes back on machine 2, machine 3, machine 4, this number is going to be the same for that particular person on your application. What it doesn't do for you is if you have a second application that you've developed on your own and submitted to the store, that user's purchase ID will be different on that other box because the date is going to be different for their purchase. So it's not a way to track a unique user, but it's a way to track a unique purchase on your particular application. The second piece of information that's interesting for this activation case, where we're trying to limit to 2 PCs, is the receipt device ID. So within an application, for a particular user, on a particular machine, each one of those pieces has a unique identifier. We hash those together and provide you this unique ID. And this unique ID, what it allows you to do is now say, I'm seeing the same receipt coming in from 3 different machines. How do I know they're 3 different machines? Well, the receipt device ID will be different for each of those machines. And every time that same machine comes back, it'll have the same receipt device ID for that user. So this is a way for you to validate how many different machines the user is using your PC on. There's obviously lots of ways that you can implement logic on the back end of your server depending on your application. There may be other restrictions or other types of abuses of your system that you're trying to track down. This is some information that you can use in that direction. So let's look and see what that looks like. What I've done is I've created a storage class that I can save receipts in and save machines that have been activated in. And I can go, when the receipt comes through, I pull out the receipt device ID. I pull out the ID for the receipt itself. And with both of those, I do a lookup to see if that receipt has been already submitted. That brings me back all of the devices that have registered for that receipt. And I can play around with some logic in here. In this case, what I'll do with that is I'll make sure that the device was registered. If it's a new receipt, I'll register it and that device comes in, no problem. If the device is already registered, then I'll allow them to go through as well. Now, say that the device is not registered yet. I'll take a look to see if there's already 2 devices registered for that particular receipt. If there are, then I will reject that device coming in. And then, obviously, if there is room, if there's only 1 device registered, I will allow this new one to register. So very basic logic here, but the idea is showing how you can use that information to track what you're doing. So if you saw in the application down here, when we're in the debug mode, the signature, the receipt that comes back, is shown as an invalid receipt. This is because the receipt is not signed when you're using the simulator. Now, if I were to go and switch over into the release mode, it will actually get a real receipt from the store service, bring it down, and I send it up to my web service, and the validation comes back successful. Just to show you some other iterations on that, if I go back to the debug mode, let's make a modification to the app receipt license, and let's say it's a trial, and we'll give it an expiration date. Let me copy it from down here. And set it to, okay, so this is an old expiration date. Oh, sorry, I'm making the modifications the wrong place. So the licensing information for the actual product when we do the simulation, let's give it an expiration date here that's in the past. So 6/27, and let's give it a try. So you can see that the response back from the server is no, it's an expired license. And this is mostly just to show you what the server will do. But most of the policy you'll implement on the server side and just block that particular license from signing into your service. So let's come back to the slides just to summarize where we're at. So the basic proof of purchase, this is something that your application can use to pass up to its service. That allows your service to identify, yes, these purchases have been made and they're guaranteed, they're real purchases, and I can trust them. It also allows you to detect other abuses of your system. So primarily, what this allows you to do is give customers what they paid for, make sure that you're giving them the features, but also to protect your service and your application, and make sure that it's honoring genuine customers and not wasting your service functionality on someone else. I put some links to the sample application that allows you to implement licensing checks on your local machine, as well as a link to the example that shows you receipts and how you can use receipts in your application. There's also a link at the bottom, and I'll explain it just briefly, just so you get a sense of something. It's kind of like homework for you to do if you want to go even further in this protecting your application. There is an application-specific hardware ID that the OS also provides you that's independent of what the store does. And this has its own logic and gives you one additional thing to play with to validate that the machines that are talking to your service are the same machine that talked to your service last time, and you can do some logic based on that to, protect yourself from some types of abuses. So I'd love to open it for questions if you have. Otherwise, I'm going to be available at the Windows Store booth in the main hall. So the question is, the hardware ID, where does that come from? So the third bullet here, the application-specific hardware ID, it's based off of some hardware identifiers. Looks at a list of different hardware identifiers on your actual machine. So some serial numbers, and it takes pieces of those serial numbers and hashes those together and uses that. There's a weighting mechanism that's used. Your application can determine kind of the weights and measures that it wants for each of the different types of hardware numbers. And then there's a tolerance built into that. So if some of the functionality, you change a hard disk or you change your network card, things like that on your PC, it'll drift a little bit and your server can detect, is this within the tolerance that I built in? Yes, it is. Great. I still consider it the same machine. And so there's some sample code as well at that link that shows you how to do that management. So the question follow-up on that is that similar to what Office is using for its own protection? It's the same approach. Yeah, same type of approach, yes. Great. Well, thank you very much.